Okay, just wanted to do this problem for you. It says finding lengths of segments in and around a circle. So they want us to find the length of this x right here. And x is a tangent to the circle because it's only touching that circle once right there, and that's called the point of tangency. So this is called a tangent. This is not called a tangent because it is a it's not touching the circle once but twice, 1, 2. And so he's actually called a secant. So let's read our theorem. When a secant segment and a tangent segment, so here's our secant, here's our tangent, are drawn to a circle from an external point. This is a point that's external of the circle. External means outside. The product of the secant segment and its external segment. Okay, so this part right here, this secant segment, that's this part from here to here, the whole thing, boom to boom. And its external segment, external again, outside segment, so it's asking for the outside segment, so that's just from here to here, so just the outside part, so that 3 labeled in this problem is equal to, so they're setting up an equation, to the square, meaning something's going to be squared, to the tangent segment, so this guy's squared. So here I go, here's my writing down. So again, the secant segment, so this part here, secant segment, that's the whole thing. So I call this my whole. So I call it whole. So the whole thing times the outside part, just the outside part, is equal to the tangent squared. Okay? So this is my little shorthand notation. So how long is this whole thing right here? The whole thing is 7 because 4 plus 3 makes 7. So we're going to put a 7 here. And we're going to multiply that by just the outside part. So how much is this outside part? It's just 3. And that's equal to tangent squared. That's equal to this guy squared. So that's x squared. And they don't want x squared, so there's my equation, right? Whole times the outside equals to the tangent squared. And they don't want x squared. They want just the x. So how do we get rid of this squared right here? So what's the inverse of x squared? How do we inverse that? How do we get rid of that squared? Well, hopefully you said the square root, because those two things will cancel, and that's what we want. We just want x to be left by itself, right? And then so if you square root one side, they've taught us to square root the other side. And I didn't multiply this on purpose because I was hoping that maybe I can like pull some people out, but there's no multiplying, there's no pairs there. So my answer is just plus or minus square root of 21. Okay, the plus or minus comes from the fact that this blue equation right here, x squared equals to 7 times 3, is like asking you what number squared, when I square it, gives me 21. And it could either be the positive value or the negative value, and so that's why we do that. But since we're in geometry and we are like thinking about like x is this length of the tangent right here, it's a length of a segment, and you really can't be negative, we're gonna scratch out this negative right here. So our answer is the positive value of the square root of 21. So x equals the square root of 21. Okay, and the way I check that is I just plug it into my equation and make sure. So here we go. It's going to be, I'll write it down here. So 7 times 3, right, whole times outside is equal to the square root of 21 squared, which, as you know, those two cancel. So we're just left with 7 times 3 equals 21. Is that true? Does 21 equal to 21? Well, since that's true, then x is right, and then ta-da, there's my value of x. And notice he's a positive value because the length of a segment can only be positive. All right, try another problem like that.